So I wanted to start off with a little bit, and obviously when we're talking about storage, a lot of what we're talking about in Iowa anyway is large round bales. And so a lot of this will focus on large rounds. Shelby talked a little bit about the different bale shape, and I'll mention that a few times, but with a big focus on the large rounds. So we know when we store large round bales outside, we're going to see a loss of dry matter, as Shelby talked about. As it picks up moisture, we see some decomposition. We're going to see a decrease in dry matter. We're also going to see a decrease in the percent of dry matter that's digestible. So in addition to just losing quantity, we're also losing quality. Some of that comes from the concentration of fiber. So we don't necessarily see an increase in the amount of fiber, but we see an increase in the percent of fiber because we're losing those digestible nutrients. Protein may or may not change, and that's going to be variable depending on the situation. But we do also see an increase in that acid detergent insoluble nitrogen. So that's the amount of nitrogen or crude protein that's digestible. But I think more importantly than just quantity losses is also the dollar loss. And I'll show you a few factors with that. And Ryan will get more into that later. Shelby mentioned some harvest things we can do that helps impact or improve storage. Part of that is that moisture at harvest. I'll also add, you notice Shelby was using moisture. I'm using dry matter. And that's the difference of our profession. So agronomists talk moisture, livestock producers talk dry matter. It's just an inversion or 100 minus the other to get to it. But forage type also makes a difference. Alfalfa versus grass legumes. Alfalfa is going to dry maybe a little slower because of that thick, dense stem versus grass. Grass tends to kind of form a mass layer or a protection around those bales when we're strictly in grass. Shape makes a little bit of difference. So we know round bales are going to shed some water off the top from the water coming on, where our square bales are not going to do that. The problem is rounds don't stack very well. So we'll have a few examples of that. Shelby mentioned the density, but I also found a few studies that look at comparing twine versus the basic plastic net wrap versus the newer B wrap. And so I'm going to talk a little bit about those from a harvesting standpoint that impacts storage as well. So this is a study that was done in Iowa. This is Dr. Russell, so it's been around for a little while, but also it looks at density as well as moisture at harvest. So you can see the moisture levels, 24% moisture versus 17. 17 is going to be very appropriate for big rounds and for small squares, but is probably also for our big squares as well. 24% moisture is going to be really wetter than we want to see put up. I'm going to skip to the bottom here first and talk about digestibility. So from a dry matter digestibility standpoint, clearly the drier the bales, the better than wet, and the more dense the bales, so the less ability for moisture to enter that bale, the better the dry matter digestibility. Crude protein, the same way. The drier it is, the better we can preserve that crude protein over time. When we look at intake, which from a cattle standpoint or a livestock standpoint is important, again, we see our hot, drier hay is going to have more digestible dry matter and more total dry matter than our wetter hays. And in general, our denser bales are going to be better than our less dense bales. This is a little bit of why, and I use this a lot of times to talk with producers. Oftentimes producers will say, well, it's only the outer couple of inches that are spoiling or are deteriorating in storage. Well, for a 5-foot bale, the outer 3 inches is a quarter of the bale, 25%. On a 6-foot bale, it's about 15%. But we start to see very quickly, even 6 to 3 inches of spoilage really gets to be a very high percentage in a hurry. And so that has a big impact. I'll show you some images later, I think help to describe that a little better. I apologize that this graph is not quite as easy to read. I couldn't get it blown up enough to see the print very well. but it's from a study in the 1990s and then was replicated in 2009 and again in 2020 that looked at both twine wrap as well as net wrap. So in this case, the darker bars are the net wrap and the lighter bars are twine wrap. And you can see when our hay bales, big round bales, are stored outside on the ground, poorly drained, soil conditions, we see about 40% loss with a net wrap and almost half a loss in a twine wrap. A little bit less when they're stored on well drained soils. As we start to move it to some kind of a stack pad, they're calling it, but gravel, tires, pallets, anything to stop the wicking of moisture from the ground up, we start to see a reduction again in storage losses. And obviously, even in a barn, we don't see zero loss. We see about 5% loss, depending on studies, when it's stored inside. But again, as we look at anything we do to get it off the ground and then get a cover over the top, we start to see a significant loss in a reduction in losses. Here's looking at the different wrapping methods. So again, this is looking at 12 months of storage on pallets. So they at least had it off of the ground. They did store it for a full 12 months, which most of us are going to store more like 6 to 9 months. But in both the twine and the net wrap, we saw at least 5% loss in dry matter, where we saw no loss in the B wrap, and about 2 to 3% loss in non-structural carbohydrates, or the sugars and the starches in that plant, and none on the B wrap. So really starting to see a benefit to this new B wrap. And I think over time, we always tend to see improvements in processes and procedures, and we can clearly see that here. This study, again, it comes from Dr. Russell at Iowa State, so it's got a little age on it. But again, looking at how we store them. So if we get them stored off of the ground, anything we do to prevent that wicking of moisture from the ground is going to reduce our losses, improve our dry matter savings. This is in savings. And if we look at $80 a ton hay, which we're a little higher than that, so we're kind of between about $100 a ton hay right now. But we're looking in that $5 to $7 per ton savings by just putting something underneath them. So I think if we start to think about the cost of pallets, tires, poles, rock, if we could save between that $5 and $7 a ton, we could probably pay for that improvement over time. When we start to put a cover over the top, he was showing $4 to $6 a ton savings. Net wrap again in that $5 to $7 savings. And the plastic sleeves, obviously, if we can wrap that whole bale in plastic, that's going to save us quite a bit as well. This is a little dated. This was a study that William Edwards did in 2017, so a little more current. He basically tried to pull all the studies he could find from the 80s forward, so in the last 45, 50 years, that compare different hay storage, and then get an average across studies, across systems, across environments. And basically what he was showing by this study is that about 27% of our hay is lost just in volume and dry matter when we store hay bales, big ground bales, outside on the ground with no cover. And I'll equate that to our corn and bean system, since we're pretty much in the corn belt up here. If you lost 27% of your corn in storage in your grain bins, would you be happy with that? And I can say without a doubt, you would say, no, you're not happy with that storage system. So I think we need to look at it from a forage standpoint and treat it more like our corn and bean grounds and say, that's not acceptable to lose almost a third of our product in storage. So what can we do if we put it on gravel or on pallets? We reduce that to 22%. If we cover it, we're down to 8% loss. If we store it on the ground, but with wraps or with tarps, we're down to 13. But when we put it out here, either under roof or in a building, we're down to 5% loss. So we're going to see that 5% loss no matter how we store it. but we need to think about getting it off the ground and something on top of it to really reduce our losses. These are some images, and I'll show you several of these here that were from a study done at South Dakota State. So very similar in our environment in terms of moisture. And then the University of Wisconsin this is a moisture image that they did. They went 8 inches in from the end, the butt end of a bale, and did a moisture analysis. And here, the more orange and dark red, the drier that hay was, the more blue it is, the lighter it was. And so this is an image of an alfalfa hay bale stored under roof. And for the most part, you can see it's pretty dry. Most of it's down under that 15% moisture, which is where we'd like it. But even stored under roof, we're still seeing some wicking of moisture on the base of that bale. Now, not a lot. You can see that very small portion at the very bottom up in that 25%, 27% moisture. But this is kind of our gold standard. So keep this in mind as I show you the next few images. So here's an alfalfa bale. Again, these were all made at the same time, off the same field, stored at the same time. I think they were stored for 12 months. And you can see just based on how this bale was set outside, so set on the round side, but you see some differences. Again, that moisture wicking from the bottom, we see a lot more blue on the bottom. We see more moisture wicking up. We see some blue on the edges. We see a difference between the east-facing side of the bale versus the west, so more moisture on the east side, probably because the west side would tend to get more heat penetration, sun penetration, that's going to kind of re-dry that over time. But you can see what a single bale. So think if you're like bale feeding in the wintertime and you set your bales out for the season, this is kind of what that bale would look like. This is an image of a bale that's set in a row. So it was a middle bale in the row. If you look up here in the blue images, the blue bales, you can see how they lined them up. So these rows were north to south, which is what we would recommend. They were set at least 3 feet apart. So we'd say 3 to 4 feet apart. And that's to allow that sunlight to penetrate the side of those bales and kind of dry them out over time. But again, we start to see a lot more blue. So these were butted up butt to butt on that row. But we see, again, that east side picking up a lot more moisture. Not getting that solar penetration, solar drying effect throughout the season. We see a lot more blue, a little blue on that top right side, again, that west side, but seeing a lot more losses. Really only the very center core of this bale is down where we'd like that dry matter to be to reduce the amount of spoilage we get. This is what bales look like when they're side to side. So again, butted together in the row, but the rows are touching each other. And I think here we start to see that real high deterioration between the bales. So think about it as those bales our rows are set close to each other. We get a rainfall or we get a snow event. The rain is going to come off the top of those bales. It's going to get in between them and kind of pool and just sit. And as that moisture pools and sits, it has the ability to penetrate into the side of those bales. Again, very, very little of that bale is really down in that 15% where we'd like it to be. Little difference on whether it's the east side or the west side. Again, the west side is going to get more sun penetration and solar benefit, but clearly demonstrates why we say space the rows out, allow room in between for the moisture to be run off and not to pool in the middle. And then here's our stacks. We'll have folks say, well, I stack them, and that works really well. It does reduce the amount of storage space we need. And that top bale that you see on the left really doesn't look too bad. It has shed a lot of the moisture off it, maybe a little more in that top right corner, but for the most part is in pretty good condition. But look at that right-hand bale, or what would be in the bottom. So all that moisture that runs off the top of the top bale is running into that bottom bale. And again, we can see a lot of that bale is in that 40 plus moisture range where we start to see a lot of molding, a lot of deterioration of the nutrient value, a lot of just general losses. So this would not be our recommendation without some kind of a cover and a base under it. And I think this is the last one of the studies. So looking at what they had here on the pyramid, again, the pyramid row running north south. And as you can see, without the cover, the top bale looks pretty good, but everything below it has started to pick up moisture, particularly on that east side. So again, the west side is probably picking up a little bit more in terms of solar radiation. But those that middle bale and the bottom bales on the east side, you can see again a lot of water loss, a lot of deterioration. So that all really kind of it leads to that recommendation that our rows go north and south, but we have room in between them. We have them up off the ground, and we try to cover them to reduce our loss. Again, this is a loss from or a study from Missouri, and it looked at not only storage loss, but how does storage also impact feeding losses. So these are kind of cumulative. We have storage loss, and then we have feeding loss. Obviously, our barn stored hay has the least feeding loss. It's in the best condition. It's very palatable. Cows are going to eat it pretty well. If we're looking at hay stored outside and uncovered, in addition to that 25 to 20 to 40% storage loss, we see an additional almost 25% feeding loss on top of that. And again, you can see with our pyramids, once we can pyramid them and cover them, we get down pretty close to that barn loss. So again, 13 to 14% feeding losses on top of our storage losses. So I'll just wrap up with a few common things. In terms of storage, we want to look at both the amount of nutrients lost as well as the amount of dry matter loss or product. Two big things, if you don't remember anything else: stop moisture from wicking up from the ground with pallets, rocks, anything you can do to get that bale off the ground, and stop water from infiltrating from above. So B-wrap, net wrap. B-wrap is better than net wrap. Plastic wrap is better yet. A roof over the top is better yet. So anything to stop moisture from wicking from the bottom or coming in from the top. And then make sure we're testing our forages for the best values to determine feeding value. So that's my presentation. If there's any questions, I'll be glad to take one or two now or turn it over to our next speaker.